about solutions. Add-on desired.
Welcome to Added Solutions. My name is Vijayaratnam. Today we are going to discuss about the set theory from 8th class IIT Maths. First, what is the meaning of the set? What is the meaning of set? Set means the definition of the set, a well-defined collection of objects. A well-defined collection of objects. A well-defined collection of objects is called a set. What is the meaning of well-defined? Well-defined. What is the meaning of well-defined? Well-defined means the particular object, which objects we are inserting the set to, the objects must be well-defined. Objects must be well-defined. Means well-defined means whenever we are expressing the nature of the object, we know about the object, then only we are expressing the nature of the object. Suppose, for example, Ravi is a good boy. Ravi is a good boy. If we know about Ravi, then that is called well-defined. He is a good boy. He is a good girl. He is a bad boy. He is not good boy. Whenever we express about the statement he, we don't know about him. That's why that is not a set. That is not a set. Here set denoted by A, B, C capital letters. Then A is equal to, we insert the objects or elements. We insert the objects or elements in the flower bracket. In the flower bracket. A is equal to set of A, E, I, O, U. A, E, I, O, U. Means set of vowels. Set of vowels. Means we expressed as the set, we denoted the set by capital numbers. We insert the elements in flower bracket. Flower bracket. This is called a set. This is called a set. Suppose number of students in your 8th class. Number of students in your 8th class. That is a set. Suppose you insert B is equal to set of Ravi, Kiran, Anita, Raju, Rani. This is called a set. This is called a set. C is equal to set of talented person, talented people or person in India. D is equal to set of richest persons in Hyderabad. This is not a set because talented people in Hyderabad, so many are there. If we particularly mention their names, then that is called a set. Here richest also not well defined. Richest also not well defined. Richest means on which basis they are richest, or money purpose or talented purpose, we don't know. That's why these are not a set. This is not a set. Here, how many types are there for the expression of the sets? Two forms. First one is roster form. Second one is set builder form. Roster form or set builder form. Roster form is also called as longest form. Here first one roster form. Roster form means suppose n is equal to set of natural numbers up to 100. We mention the all elements. We mention the all elements in the set. Then that is called roster form. Roster form is each and every element we have to insert the set. That is called roster form. Set builder form or shortest form we no need to write all elements. We no need to write all elements. Instead of elements, we can use a symbol or a letter. We can use a symbol or a letter. Means here n is equal to set of x such that x belongs to natural numbers and n belongs to n less than or equal to or x less than or equal to 100. The same set. We no need to write all elements. Instead of elements, we have to write a letter or a symbol. This we can read as x such that x belongs to n, x less than or equal to 100. X less than or equal to 100. This is called a set builder form and roster form. Set builder form and roster form. Next one, how many types of sets are there? How many types of sets are there? Types of sets. First one, finite set. Finite set. Finite set means number of elements are uncountable. Number of elements are uncountable. Countable. Number of elements are countable is called finite set. Finite set. For example, P is equal to set of A, E, I, O, U. A, E, I, O, U. Here how many elements are there? 5 elements are there. How many are there? 5 are there. Means number of elements in a set are countable. That is called finite set. Infinite set. Infinite set. If number of elements are uncountable, number of elements are uncountable, is called infinite set. Suppose for example, K is equal to set of 1, 2, 3, so on. How many are there? Not there. So many elements are there. How many elements are there? So many elements are there. P is equal to set of K is equal to 1, 2, 3, so on. Set of K is equal to 1, 2, 3, so on. Or R is equal to set of real numbers. Real numbers, how many are there? So many are the real numbers. Natural numbers, integers, whole numbers, rational numbers. These all are called real numbers. These all are called real numbers. Suppose for example, between 2 and 3, number of irrational numbers. Irrational numbers between 2 and 3. In 2 and 3, how many numbers are there? No numbers are there. But how many irrational numbers means infinite irrational numbers between 2 and 3. Infinite irrational numbers. Infinite rational numbers also. Rational numbers also. Infinite numbers between 2 and 3. That's why the type of sets are called infinite set. The type of sets are called infinite set. Next one, third one is null set or empty set. Null set or empty set. If a set has no elements, if a set has no elements, is called null set or empty set. It is denoted by this, can be read as pi. Pi, or this symbol we can use for express as null set or empty set. Null set or empty set. Next one, universal set. Universal set. Next one, universal set. Universal set means universal denoted by mu. Denoted by mu. All sets are, or all elements are, is a part of universal set. Then the set is called universal set. Suppose for example, in your school is universal set. Remaining all classes with including sections 1 to 10th classes, these are called elements, and these all belongs to school. All belongs to school. All districts belongs to state, then state is called universal set. All states belongs to country, then the country is called universal set. All countries belongs to world, then world is called universal set. World is called universal set. Suppose here you can take n is equal to set of 1, 2, 3, 4, 5, 6, so on. Natural numbers are there. Natural numbers. E is equal to set of 2, 4, 6, 8, 10. Even numbers. Even numbers. O is equal to odd numbers 1, 3, 5, 7, 9. These are called odd numbers. P is equal to prime numbers 2, 3, 5, 7, 11. These are called prime numbers. Means all even numbers are a part of natural numbers. All odd numbers are natural numbers. All prime numbers are also called as natural numbers. That's why here for E and O and P, means for even numbers, for odd numbers, and for prime numbers, N is called universal set. N is called universal set. Understood? Next one, equal sets. Equal sets. Equal sets. If two or more elements are having same elements, then the sets are called equal sets. Then the sets are called equal sets. Suppose for example, A is equal to set of vowels A, E, I, O, U. B is equal to set of vowels in English alphabets. Set of vowels means A, I, O, U. Therefore, here A is equal to B, equal sets. Equal sets. Next one, equality sets. Equality of sets. Equality of sets means number of elements are same. Number of elements are same in two sets, two or more sets are called equality of sets. Are called equality of sets. Suppose A is equal to 1, 2, 3, 4. A is equal to 1, 2, 3, 4. Then B is equal to A comma B comma C comma D. A, B, C. Here how many elements are there in A? 4 elements. How many elements are there in B? 4 elements. Then A is equality to B. The symbol we can use for equality symbol. A and B are equal sets. Next one, cardinal number of set. Cardinal number of sets. cardinal number of sets means the number of elements represents in a set is called cardinal number of sets. P is equal to A comma B comma C comma D. How many elements are there? P. 4 elements are there. N of P is called cardinal number of P. N of P is called cardinal number of P is equal to 4. N of P is equal to 4. Number of students, cardinal number of 8 means in 8th class number of students how many are there? Suppose for example 30 students are there. N of 8 represents number of students in 8th class. Number of students in 8th class 30 students, that is called cardinal number of students. Cardinal number of students. Now we can see synopsis 1 set theory. Introduction. In everyday life we have to deal with the collection of objects one kind of the other. For example, collection of even natural numbers less than 12 is equal to 2, 4, 6, 8, 10 or even numbers less than 10. The collection of vowels in the English alphabet A, E, I, O, U. A, E, I, O, U. Collection of English alphabets. Vowels. Next one, the collection of all natural numbers that divide 12 means 12 divisors or 12 factors. 12 factors. 1 is the 12 factor, 2 is the 12 factor, 3 4s are 12, 4 3s are 12, 6 2s are 12. Next to 12. These are called divisors of 12 or 12 factors or 12 factors. A well-defined collection of objects are called a set. Well-defined collection, we mean that given set an object, it must be possible to decide whether or the object belongs to the set. Whether the object or element belongs to the set, that is called well-defined. The objects are called the numbers or the elements of the set. These objects are also called as members or elements of the set. Sets are usually denoted by capital letters. Their members are denoted by small letters. We write the elements of the set with the braces flower bracket. If X is a member of the set S, we write as X belongs to S. X belongs to S. Read as X belongs to S. And if X is not a number of the set, then X does not belongs to S. Belongs to, does not belongs to. Ravi belongs to Andhra Pradesh or Raju belongs to Telangana. Raju does not belongs to Andhra. Ravi does not belongs to Telangana. Joe Biden does not belongs to America. Does not belongs to India. Does not belongs to India because he is an American. He is an American. Means here belongs to means that particular element in the set that we denoted as belongs to, read as belongs to. If the particular element is not in a set, not a part of a set, then we can use does not belongs to. If x and y both belongs to S, we write as x comma y belongs to S. Means x and y are two elements in a set S. Two elements in a set S. Representation of sets. There are two ways to represent a set. Roster form or tabular form or list form or long form. Same only. Roster form or tabular form or list form or longest form. In this form, list all the elements or all the members of the set. Separate this by commas and enclose this with the braces, curly brackets or closed brackets. The set of S of even natural numbers less than 12 in the tabular form written as S is equal to set of all elements we represent in the set 2, 4, 6, 8, 10. Note that here 8 belongs to S and 7 does not belongs to S. 7 does not belongs to S. 8 belongs to S and 7 does not belongs to S. Is it 12 belongs to S? No. 12 does not belongs to S. Means we listed all elements in the set, that is called roster form. The set of S, the set S of prime natural numbers less than 20 in the tabular form is written as prime natural numbers 2, 3, 5, 7, 11, 13, 17, 19 are prime natural numbers less than 20. Less than 20. This is called roster form or tabular form or list form or longest form, we represent all elements in the set. The set n of natural numbers in the tabular form is written as n is equal to set of 1, 2, 3, so on. The dots indicating infinitely many missing positive numbers. N is equal to set of 1, 2, 3 commas. After dots represents infinitely many missing positive numbers. Next, second one, set builder or rule form or short form. Set builder form or rule form or short form. In this form, write one or more, if necessarily, variable, say x comma y, representing an arbitrary member of the set. This is followed by a statement or a property which must be satisfied by each member of the set. Means instead of a number, all numbers, instead of all names, we represent or we use a symbol. Or arbitrary number of the set, followed by the given statement or any property. Example, the set S of even natural numbers less than 12. In the set builder form, here written as x is equal to S is equal to set of x such that x is even natural number less than 12. X is an even natural number less than 12. Is an even natural number less than 12. Next, the set of prime natural numbers less than 20 in the set builder form is written as x is equal to x such that x is a prime natural numbers less than 20. X is a prime natural number less than 20. We use the symbol. The symbol such that stands for the word such that or where. Sometimes we use the symbol, this symbol also, or this symbol in place of the symbol I. Means suppose x such that x belongs to n. We use two dots, x such that x, instead of that one we use this one, two dots, then that is called x such that x belongs to n. The set of n natural numbers in the set builder form is written as x is equal to x such that x is a natural number. X is a natural number. This is infinite set. Next one, some standard sets. We enlist below some sets of numbers which are most commonly used in the study of sets. First one, the set of natural numbers are positive integers. It is usually denoted by n. N is equal to set of 1, 2, 3, 4, so on. The set of whole numbers, it is written as W is equal to set of 0, 1, 2, 3, so on. Set of integers are denoted by I or Z, is equal to all negative numbers, positive numbers including with 0. Set of so on, minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. The set of rational numbers are denoted by Q. Then Q is equal to x such that x is a rational number, or Q is equal to set of x such that x belongs to m by n or p by q, where n is not equal to 0. M and n are two integers. Next one, the set of numbers, it is usually denoted by R represent real numbers. X such that x is a real number, or R is equal to x such that x is either a rational number or an irrational number. Here I is equal to square root of minus 1. Here I represents imaginary numbers. Imaginary numbers means in square root any negative numbers are there, that numbers are called imaginary numbers. Next, types of sets. First one, empty set. A set containing no element is called empty set. It is also called as null set or void set. There is only one such set. It is denoted by pi or empty set without no elements. For example, the collection of all integers whose square is less than 0. Is empty set. Square of an integer cannot be negative. The order of the empty set is 0. Next, singleton set. A set is said to be only one element in the set. That set is called singleton set. Only one element. The set of 7, set of minus 15 are singleton sets. Here x such that x plus 4 is equal to 0. Means x plus 4 is equal to 0. This implies x is equal to plus 4 transpose set minus 4. This is equal to set of minus 4. Then this is the examples for the singleton sets. Next, the set x such that x plus 4 is equal to 0 is a null set because there is no natural number which may be satisfies equation x plus 4 is equal to 0. When this x belongs to n given, x belongs to n. If x is equal to minus 4, x is equal to minus 4 is integer, minus 4 is integer. But here given minus 4 does not belong to natural number, that's why this is called null set or void set. Null set or void set. A set whose order is 1 is called singleton set. Thus a singleton set which contains only one distinct element. One distinct element. Singleton set means a set has only one element is called singleton set. A set no elements are called, that is called empty set or void set or null set. Next, for example, A is equal to set of x such that x is a positive divisor of 20. Positive divisor of 20, then n of A is equal to 6. Means number of A means number of elements in A is equal to 6 elements. Positive divisors of 20, 2 is positive divisor, 1 is positive divisor, 2 tens are 20, 4 5s are 20, 5 4s are 20, 10 2s are 20, 21s are 20. Means how many are there? 1, 2, 3, 4, 5, 6. N of A is equal to 6. N of A is equal to 6. Next, x is B is equal to set of x such that x is a positive even prime. Even prime means only 2 is even prime. B is equal to set of 2. B is equal to set of 2 is called even prime number. N of B is equal to 1 means B is equal to set of 2. Note that B is singleton set. B is singleton set. Only one element is there. If C is equal to set of x such that x is an integer neither positive nor negative, then n of C is equal to 1. Then C is equal to set of 0. Set of 0. C is called singleton set. Means suppose you write like this, 0 is also one of the element in the set. 0 is also one of the element in the set. That's why this is a set. This is not a null set. Finite and infinite set. Set is called finite if the process of counting of different elements comes to an end. Otherwise it is called as infinite. The empty set is taken as finite set. The empty set is taken as finite set. Means in a set too, number of elements are countable, that is called finite set. Number of elements are uncountable, then that is called infinite set. The empty set is taken as finite set. Empty set is taken as finite set. The set S is equal to 2, 4, 6, 8 is finite set. The set of all students studying in a given school is a finite set. The set of n of natural numbers is infinite set. Means natural numbers are so many are there. The set of divisors of a given natural numbers is finite set. Divisors. Next, the set of all prime numbers is a infinite set. Means prime numbers so many are there. That's why set of all prime numbers are called infinite set. Yet divisors are finite set too. Divisors are finite set means factors. Number of a given factors are finite set. Finite set. Order of a set. Order of a finite set. The number of different elements in a finite set is called order of S. It is denoted by O of S or N of S. The order of an infinite set is not defined. The order of infinite set is not defined. Only finite set are defined, that is called as O of S or N of S. Means cardinal number of set. Cardinal number of set. Equivalent sets. Two finite set A and B are said to be equivalent, written as like this: A is similar to B, or A is like this. If they contain the same number of distinct elements, n of A is equal to n of B. If and only if n of A is equal to n of B. Means number of elements in A is equal to number of elements in B, then that sets are called equivalent sets. Here the sets set of 1, set of 2 are equivalent. Why? Because 2 repeated 3 times, but you should only take one time, set of 2. If elements are repeated 3 or more times same element, you should write only one time. The set of 3 comma 4 and set of x is equal to x square is equal to 4 means x is equal to plus or minus 2. Means this is equal to minus 2 comma plus 2. Here elements are 2 are there, here also elements 2 are there, minus 2 comma 2. That's why the two sets are called equivalent sets. Two sets are called equivalent sets. The sets A, B, C, D, E, here 5 elements are there. Here 1, 2, 3, 4, 5, here 5 elements are there. Here A, E, I, O, U, here 5 elements are there. These 3 are called equivalents because each set having 5 distinct elements. 5 distinct elements. Equal sets. Two sets A and B are said to be equal, written as A is equal to B if and only if every member of A is member of B, every number B is a member of A. Means if A and B are having same elements, same number of elements, so same elements, then the two sets are called equal sets. Equal sets. Equal sets also called as equivalent sets, but all equivalent sets are not equal sets. Remember this. All equal sets are called equivalent sets. Why? Because number of elements are equal in two sets. But all equivalent sets are not equal set. All equivalent sets are not equal sets. Example, the sets minus 1 comma plus 1, here x square is equal to plus 1, x square is equal to 1. This implies x is equal to plus or minus 1. These two sets are equal. These two sets are equal. Here set of 0 comma 0. Here set of 0 comma 0 means 0 only. Set of 3 are not equal, but they are equivalent sets. Why? Because number of elements are same in the two sets. Number of elements are same in the two sets. Cardinal number of set. The number of distinct elements contained in a finite set are called cardinal number of, and it is denoted by n of A. A is equal to 1, 2, 3, 4, 5. Then n of A is equal to total number of elements in set A is equal to 5. Here n of B is equal to 3 elements are there. N of B is equal to 3. N of B is equal to 3.
Add-on solutions. Add-on desired.